Now for the helium atom, I'm going to leave this set up so that you still see that we have the same sort of movie theater with the same number of seats here, or the same shelf with the same number of buckets on each of the shelves, right? But what we're changing now is what is in those buckets, right? And so this time we're going to add another proton. So we have now two protons, right, for a total charge of +2, right? And then we have, for a helium atom, in its basic form, it wants to have two electrons. We're going to go ahead and put two electrons there, right? Okay, so then it's going to basically have two electrons for a -2 charge. And then also we have something new that's going to occur for a helium atom. We actually have two neutrons with zero charge. So those do not add to the total charge, they just add to the total mass. So when we count up our mass, what we find is that the mass of a helium is actually going to be, we have two protons and we have two neutrons, and so we end up with about 4 atomic mass units. So this is how we start to build our periodic table. Okay, so now what is actually the difference between these atoms? Well, again, with a helium atom, I can actually take away some electrons or add some electrons. So I could make a helium atom with a single plus, and what that means is that I've taken away an electron. Okay, and what that means is that it has a total charge of +1. Or I could, sometimes they'll say 2 plus, or they'll just say plus plus, so that you can see that there are two electrons that have been taken away from the helium atom. You can't have three taken away because there's not three to take away. And what that means is that we've gone away from the basic state and created something called an ion, same as we did with our hydrogen atom. When you start removing or adding electrons from the shelf, you're creating an ion. So it's important to note that the reason that we generally have +2 and -2 here is because these atoms do desire to be neutral. They don't want to have excess electrons or deficient electrons, at least for electrostatic reasons. Now, there are other reasons that they may want to gain or lose atoms, and we will find out when we get to chemistry that there is a competing reason with this trying to stay neutral. So staying neutral is one of the atom's greatest objectives. The other one we will find out in chemistry. So let's look at this again. We can take one of these charges here, and we could actually cause it to leap up to the higher level here if we wanted to, and we would then therefore be raising the energy of our atom. And then when it comes back down again, then it loses that energy. So we can have atoms in excited states. I kind of like to look at it like if you drink coffee and then you get like hyper for a while, and then after your coffee wears off, then you, you kind of you come down from that coffee rush and you're just again, right? So that's kind of the way that we can look at the energy on this atom. So all right, what is actually different though about a helium atom and a hydrogen atom? Now, this is a very fundamental question to the way that we construct atoms and the way that we've constructed our periodic table. Because you might say, well, there's lots of differences. One difference is that the electrons, it wants to have two electrons. And one difference is that these two neutrons have appeared here. And then one difference is that we have two protons, right? But let me give you another feature, okay? It's totally possible to remove electrons. It's also totally possible for us to remove neutrons. I don't know if you saw that I deleted this neutron. But it's also totally possible for us to remove neutrons. What we would do then is change about our atom. Oh, this is not an ion. I was just writing that that can be an ion if you take away the two charges. What we have done here is we've said there is one neutron, and therefore it has now an atomic mass of 3 because it has 2 protons and 1 neutron. It still has 2 electrons because those 2 electrons want to balance out the 2 proton charges. Now, the question is this a helium atom? Yes, it is. It is a helium atom, and we actually call this an isotope. But this is a helium atom that weighs a little differently than your standard helium atom. They don't happen as often, but it's totally possible that they could happen. So that number of neutrons and the number of electrons definitely do not uniquely characterize this thing as a helium atom. But there's one thing that does. That's the number of protons. So, we have now discovered the thing that it is that causes one element to actually be that element. Let's take a look at what is absolutely required for our next atom in the series, the lithium atom. So I'm sorry if my layers got all weird here. The lithium atom has it's the next in line. So we had hydrogen had 1 proton, helium has 2 protons, lithium has 3 protons. This is the definition of lithium, excuse me. Lithium is defined by the fact that 3 protons are at the center of that atom. You cannot have a lithium atom with 4 protons or 2 protons. If it has 3 protons, it is a lithium atom. So we have to put 3 protons there. And then we can ask the question, okay, what's next? If we have these 3 protons, what can we say is the positive charge due to this? We would have a positive 3 added by our protons, right? Can you guess how many neutrons this is likely to have? It turns out that the number of neutrons, it tends to have the same number of neutrons as it has protons. So there are 3 neutrons, 3 protons. This is just a naturally occurring phenomenon. And then the electrons, well, if this thing wants to be electrostatically neutral, then it needs to have 3 positives and 3 negatives. So we would naturally want to form 3 electrons. Now, we cannot put our 3rd electron on this first shelf. All the boxes are taken. So we need to move up to the next shelf, and that is now the ground state of lithium. Now, it's totally possible that we could have this go up to this layer. It's totally possible to move these, and that happens all the time, that these electrons pop up to the next levels and back down again. It's very temporary. But if it's down here, we got 2 on the bottom shelf and then 1 somewhere on this next shelf, then we have the ground state. There's nothing particular about that spot. It could choose this one if it wanted to. It's still with the ground state. Okay. The atomic mass, hopefully you can figure that one out. The number of protons and the number of neutrons is what determines that. It is also, so here I forgot to draw my neutrons in there. It is also possible that we could create a lithium isotope. This is given as I said helium. I keep saying helium. This is given as lithium-6, which is the natural mass of lithium. But we could have a lighter lithium atom by taking away one of our neutrons, in which case we would then have only 2 neutrons, which would give us then, if we have 2 neutrons, we would have a total mass then of 5. So this would be called lithium-5. Okay. Now, lithium-5 has obviously 5 atomic units here in the middle. Still, it has 3 electrons because 3 of those in the middle are 3 positives, and it still wants to counter those 3 positive charges, right? And so we call that a lithium isotope. That is an isotope. Okay. Okay, so now we know how to build our periodic table. Let's take a look at the periodic table. Okay, our periodic table here is constructed in much the same way that we just looked at in our atom. Look here at the first row. Here we have hydrogen and helium, and that represents the fact that there are two seats. Here's the first seat, and here's the second seat on our bottom shelf, right? And then when we get to lithium, we had to go to the next shelf. Well, look at this. There are a couple of seats here, and then there are 6 more seats over here for a total of 8 seats. That is our n equals 2 shelf. Here is our n equals 1 shelf. Here is our n equals 3, n equals 4, and it keeps going. So you can actually construct your atoms by looking at this periodic table. We know that hydrogen has 1 proton, helium has 2 protons, lithium has 3, beryllium has 4. This is given as the atomic number. The atomic number and the number of protons are the same thing. So we can look at this and say, what about oxygen? It has the atomic number 8 and therefore has 8 protons. Okay, so this is our introduction to the atom and how it plays out in the periodic table. We're going to look at some more atomic features in the next video, and I hope that you're as excited as I am.